Okay, so today we're going to prove the 30, 60, 90 triangle theorem, which states in a 30, 60, 90 triangle, the length of the hypotenuse h is 2 times the length of the shorter leg s. So we can see the hypotenuse BC is opposite 90 degrees, right? And we can see the length of the shorter leg, which is AB, is going to be opposite of 30 degrees, making that the shorter leg, right? And the length of the longer leg, L, the longer leg because it is opposite of 60 degrees. So we know AC is the longer leg because it is opposite 60 degrees, is the square root of 3 times the length of the shorter leg. So we know that L is equal to S times the square root of 3, where of course S is the length of that shorter leg. Okay, so this is basically saying if triangle ABC is a 30, 60, 90 triangle, then the hypotenuse H is equal to 2S, and the longer leg is going to be S times the square root of 3, and of course S is the shorter leg. So starting this proof, you can see I drew this triangle here. Notice all I did was I rotated triangle ABC to the left, where AB would be the base, right? And I drew triangle ADC adjacent to triangle ABC, right? To form this equal angular triangle, right? We can see it's going to be equiangular because this is 60, 60, and 60. If I were to look at BCD, it would be equiangular. Okay, so now I'm going to sort of describe what I did in that picture. So I rotated, so rotate triangle ABC to the left so that AB is the base, and draw a triangle ADC adjacent to triangle ABC, right? So just describing what I did here, right? Okay, so notice I have an equiangular triangle, but I also know this is isosceles, right? So I know that the measure of angle B is equal to 60. I know the measure of angle D is equal to 60, right? So, of course, using the isosceles triangle theorem, I know that this guy is congruent to this guy, right? I know that BC is congruent to DC, right? I know that these two guys are congruent. What I also know is since this guy, so I'm going to write that down, since I have BC congruent to DC, and I have AC perpendicular to BD, right? And AC is perpendicular to BD. I know by the perpendicular bisector theorem that AC is not only perpendicular to BD, but it is the perpendicular bisector of BD, right? So this implies by the perpendicular bisector theorem that AC is a perpendicular bisector for BD, right? So, of course, this means if it's a bisector, that means AB is congruent to AD, right? Okay, so this means that AB is congruent to AD, right? So, as you can see, I'm continuing the picture. So I have BC congruent to DC. I have AB congruent to AD. So now I'm going to actually start labeling them accordingly, where I'm going to label each hypotenuse H, the longer leg L, and the shorter leg S. And I'm going to try to get it to where H is equal to 2S and L is equal to S times the square root of 3 to complete this proof. So I'm going to let let's see, AC equal L, right? Because that's the length of the longer leg in both of these triangles. I'm going to let BC equal H, which equals, so BC equals H, which equals DC, right? So H and H. And I'm going to let AB equal S, right? S, because that's the length of the shorter leg, S. And that's equal to AD, right? So I'm going to have this guy here as S as well. So now I have at least all of them labeled. Now I just have to show that H is equal to 2 times S and L is equal to S times the square root of 3 in order to complete this proof, right? Well, like I was saying earlier, I know that BCD is equiangular, right? So I know that triangle BCD is equiangular. So I have BCD is equiangular. This implies that triangle BCD is equilateral. Okay? And of course, this implies, so if this is equilateral, that means BD is equal to BC, which is equal to DC, right? Okay. So I know that BD is equal to BC, which is equal to DC, right? So of course, this implies, so BD is 2S, because it's going to be S plus S. That means BC is 2S, right? Which is exactly what we wanted, 2S. And CD is 2S, right? If we know this is an equilateral triangle, this has to be 2S because BD is 2S, and this has to be 2S because BD is 2S, right? So this implies that, let's see, this implies that BC is equal to 2S, which is equal to DC, right? So all of these are 2S, right? Now what we can do is we know both of these are right triangles, and I have this length and this length here. I just want to find L. So of course, for this 30, 60, 90, I can use the Pythagorean theorem, right? So by the Pythagorean theorem, I know that S squared, right? One of the legs, so S squared plus L squared, the length of the other leg, right? L squared is equal to hypotenuse squared, right? Which in this case I know is 2S, so it'll be equal to 2S squared. Of course, this implies that S squared plus L squared is equal to, so 2S times 2S is 4S squared. I can subtract S squared from both sides to get L squared is equal to 3S squared. I can take the square root of both sides, right? So this implies that the square root of L squared is equal to the square root of 3S squared. And then, of course, we know L is going to be positive, so the square root of L squared is just going to be L is equal to, and we could separate this to be the square root of S squared times the square root of 3. I'm using the commutative property and the property of square roots in order to separate these guys, right? Because remember, the square root of a times b for real numbers a and b is equal to the square root of a times the square root of b. So I'm using that. And then I know S is positive, of course. So this implies that L is equal to S times the square root of 3. So look at what I have. I know now that L is equal to S times the square root of 3. So I have S is the shorter leg, the length of the shorter leg. L is the length of the longer leg, which I found to be S times the square root of 3. And I found the hypotenuse of this triangle to be equal to 2S, which is exactly what I wanted to prove. So that is the proof of the 30, 60, 90 triangle.